In this video, we are going to talk about K-maps or Karnaugh maps. Okay, so that's what we are going to learn. What are K-maps? Well, K-maps provide us with an alternative way to solve expressions, logical expressions. Instead of using the 3i, 3d and car laws in Boolean algebra, we are going to use another alternative way to solve a given expression, logical expression. So, first of all, we need to talk about some of the important rules. Okay, so when I say rules, now we are going to talk about only the sum of products expression. Okay, do you remember sum of product expressions? For example, if x is the given expression, let's say it is given as a c bar d plus bd plus abc. Okay, so let's say this is the given expression. Well, in this specific expression, okay, if you consider this is a product. This is a term that is given as product. This is a term that is given as product. This is a term that is given as product, and they are combined using OR gates. Okay, so this is what we call a sum of product expression, SOP expression. Okay, so K-maps, we are learning K-maps, but now we are going to talk for only sum of product expression. Okay, only for sum of product expression. We are going to talk about POS in another video. Okay, POS is a different story. So we will be talking about POS in different video. For now, let's focus on SOP only. Okay, so first of all, since we are talking for SOP, the first rule that we are going to learn is we can't allow any zeros. Okay, we can't allow any zeros because we know when we are talking about SOP, we use the min terms, right? We use the min terms, and min terms are terms where the combination or the combination, min terms are terms or combinations where the output is equals to 1. The output is equals to 1, not 0, 1. So that's why what I mean by no zeros is that you can't choose any term that is not a combination of output equals to 0. Okay, if the output is equals to 1, well, good, you can choose that term. But if the output is equals to 0, you can't choose that term. Okay, keep that in mind. Second one, K-map is like a rectangle. Okay, it can be also square, obviously. Okay, it can be a square, but it's a rectangle. Mostly it's a rectangle. And that rectangle, normally we know, right? Let's draw a rectangle. Okay, let's say we have a rectangle like this. Okay, 4 by 2, 2 by 4 rectangle. Okay, so we have a 2 by 4 rectangle. All right. So in this rectangle, this direction can be considered as diagonal direction. Don't you think? This is a diagonal direction. This is a diagonal direction. This is a diagonal direction. Okay, or this is also a diagonal direction. This is also a diagonal direction. This is also a diagonal direction. So in K-map, when we are finding patterns, we are going to find patterns. Okay, we do not allow diagonals. Okay, we do not allow diagonals. You can only use the horizontal lines. Okay, you can only use horizontal lines and vertical lines. Okay, it doesn't matter which direction you are going, vertically upwards or vertically downwards. Okay, as long as it is not a diagonal, you're safe. Okay, as long as it is not a diagonal, you're safe. So the second rule, no diagonals when grouping. Okay, so I'll teach you what is grouping is, but just keep in mind the grouping should be done without diagonals. Okay, and then third one. Okay, third one, we can only have the number of cells. Okay, so if you look at here, okay, if you look at here, there are 8 cells, right? 2 by 4 means we have 8 cells. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and when we are using, this is for 3 inputs. Okay, this K-map is for 3 inputs. I'll teach you what is all these things, but just make yourself aware that the cells, this is called a cell. Okay, this is called a cell in K-map. Okay, and the K-map is normally a rectangle. It can be a square. It can be a square. Okay, it's normally a rectangle, and this rectangle should always contain the number of cells. The number of cells the K-map contains should be equal to the power of 2. It can be 2 to the power 0. It can be 2 to the power 1. It can be 2 to the power 2. It can be 2 to the power 3, etc., etc. Okay, so always keep in mind only power of 2 cells. only power of 2 cells. Okay, and then we have the fourth one. Okay, grouping. Okay, so what is grouping? Well, now it's time to learn about grouping. So what is grouping? Well, if you have 8 cells, let's say we have like one here and one here and another one here. You don't know what this one means. Okay, I haven't taught you, but it's fine. Just say you have ones like this in 8 cells. Okay, and when I say you have to group these things, well, you will be thinking like, how can I group this? What do you mean by grouping? Well, just connect consecutive terms. That's all. Just connect consecutive terms in horizontal direction or vertical direction. That's all. Okay, horizontal direction or vertical direction. So I told you, right? No diagonals. You can't group like this. Okay, diagonally they are consecutive to each other, but we can't group like this. We can only group in horizontal direction or vertical direction. So when you are doing this grouping, okay, when you are doing this grouping also should contain the power of 2 cells. Okay, grouping should also contain power of 2 cells. Grouping only has power of 2 cells. Okay, power of 2 cells. Okay, it can be 2 to the power 0, it can be 2 to the power 1, it can be 2 to the power 2, it can be 2 to the power 3. Okay, so that's the rule. When you are grouping, okay, when you are connecting the consecutive terms like this, you have to keep in mind you can only group power of 2 cells. Just because let's say there is something like this, okay, let's say there is another one here. Just because there is a one here, you can't group like this. Well, there are 3 consecutive terms. Why shouldn't I? Okay, there are 3 consecutive ones. Why shouldn't I group it? You can't group it because the main reason is 3 is not a power of 2. So you can group like this or you can group like this. Okay, and here you can group like this also since it is vertical. Okay, so keep in mind when you're grouping, the group should also have only power of 2 cells. Okay, power of 2 cells. Well, you will be thinking like, well, then how can I group this? This one is alone, right? This one is alone from other people. Okay, so should I group this? That's where we speak about the fifth rule. Every one must be in a group. Okay, so therefore, if you see an individual one, you have to group that also. If you see an individual one, you have to group that also, whether you like it or not. Okay, so let's just erase it for now. Okay, let's just erase it for now. All right, so let's continue talking about the rules. Okay, let's say you have groups, you have something like this, 1 1 and 1 1. Okay, now you can group, you'll be thinking like, well, I can group like this, I can group like this, or I can group like this, or I can group like this. This is what you will be thinking, right? Because I told you, you can only group horizontally or vertically. Okay, there is a sixth rule, okay, that changes a little bit of the dynamics. Okay, the group should be the largest group. Group should be the largest. Okay, what do I mean by this? What do I mean by this? Well, since we have 4 here, okay, since we have 4 here, we can connect all these 4 without any issues. You can connect all these 4 without any issue. Okay, I know here we are using horizontal direction as well as vertical direction. It is possible. It is possible to have like this. Okay, and you should agree. I mean, you should be fine. You should group it all together because the sixth rule states that the group should be the largest. Okay, I know there are other groups also possible. Okay, I know the other groups are possible like this, like this, like this, like groups of pairs. Okay, groups of pairs, that is possible. Also groups of singles are also possible. Okay, groups of singles, that is also possible. But what do we need? The largest. Since we have 4 inputs here, we use all 4 inputs whether we like it or not. Okay, so that's the sixth rule. Okay, that's the sixth rule. Now let's talk about another one. Okay, another rule, seventh rule, that states overlapping is fine. Overlapping is fine. What is overlapping is fine? Well, let's say you have a 1 here. What can we do here? Well, you will be thinking like, well, there is a group here, so I'll just put a 1 here. That's enough. That's enough. Well, you can't do that. Okay, since this one is consecutive to this one, you have to group this also. Okay, you have to group this also. Obviously, we can't diagonally make a group. Obviously, you can't do that. Yeah, but horizontally, since this is a possibility, you will do that. Okay, what if you had a one like this instead of here? What if you had a one like this? Well, then you will group all these four. Why not these two? Okay, you have to group all these four. And my question is, why not these two? Why not? Well, they are not the largest. Okay, the largest group possible in the first row is all four cells. Okay, in first row is all four cells. So you have to group like that, whether you like it or not. That's the rule. Okay, so we have to follow the rules. We like rules. Okay, and then we also give another rule that states that we can do wraparounds. Okay, we can do wraparounds. Wraparound. What is wraparound? Well, that's a new thing that we are going to do. It's like thinking in a three-dimensional way. Okay, so let's say you have a one here and you have a one here. You can actually think like this. Obviously, from these 7 rules, we have not talked about the 8th rule. So from these 7 rules, you will be saying like, well, this is an individual one and this is an individual one. So I have to mark these two as groups. Okay, I have to mark these two as groups. Well, it's not exactly right. Okay, since the 8th rule suggests us that we can wrap around things, okay, you can actually do that without any issues. What do I mean by wrap around? You can go like this. Okay, you can go like this. I mean, if this rectangle was curved into a cylinder, okay, if this rectangle was curved into a cylinder, okay, this one and this one will come together. Don't you think? This one and this one will come together. So they are consecutive to each other. So you can wrap around. Okay, not only vertically. Okay, you can do that horizontally also. I mean, not only horizontally, you can do that vertically also. Okay, I mean, here they are consecutive to each other. But let's say there is an instance where you have 16 boxes. I mean, 16 cells. Okay, let's say you have an instance where you have 16 cells like this. If you have 4 inputs, there will be 16 cells. And there is a one here and here. Okay, well then you can wrap around like this. Okay, I'm just giving you examples. Don't take this too seriously. When we do some questions like 10 or 20 expressions, you will be set. Okay, just just know these tools. Okay, so so that you won't get confused when we do questions. That's all. Okay, so wraparound is allowed. And then the last and final rule. What is it? Well, last and final rule is use as small number of groups. Small number of groups as possible. Use as small number of groups as possible. Why is that? Well, this is a simplifying process. We are not writing pieces. Okay, so keep in mind. Okay, so that you don't use too much of groups. Okay, when it is possible, just do the larger group, and then you can stop working with that. Okay, so these are the rules.
Thanks for watching the 27th video in our Logic 8 series. If you found this guide to the rules of K-Maps helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to Master Logic Gigs, and follow us on Instagram. I will see you in the next video. Until then, keep learning and stay curious. Bye-bye.